Hi guys, we're gonna wait for about 1 to 2 minutes for more people to come in. Thank you.
Hello everyone and welcome to today's workshop. I'm Yikting and I'm one of the OICs of BuildingBloCS 22. It's really great to have everyone here today. We are having the Intro to C++, C++ for Newbies workshop hosted by Ling Song, Gabriel, Iker, and Callista. So BuildingBloCS is this by student for student event where we hope to spread the love for computing. And this year it is our 6th edition. Previously, we have been hosting this nationwide in Singapore, but this year we are doing the outreach internationally. So this March conference, we have students from Japan and more international students will also be joining us in our further conferences. We are having a few conferences. This first one is during March, so stay tuned to join the Fossation 1 and the June flagship conference with many more workshops and competitions. We hope to see you along with your friends. And do follow our Instagram at BuildingBloCS22 and stay active at the Discord community as well. I'll send the links in the chat now. But before that, let me pass the time to the intro to the C++ team. Please turn on your cameras and interact with the organizers and mute accordingly. Thank you very much.
Hi everyone, my name is Callista, and me and my team from ACJC Tech Council will be conducting a workshop called C++ for Newbies to introduce you to the coding language C++. Don't be worried about not having prior coding experience, as this workshop's meant for absolute beginners. So to start off, we'll be going through a few things. First off is why C++. Why C++ is used in the industry and how it can benefit you. Next, we have running C++, how we can run our own code on our laptops. Then, the syntax, how we structure our code so it makes sense for the computer. If-else conditions, a conditional statement that runs a different set of statements depending on whether the expression is true or false. So, for example, if a condition is met, A will happen, else B will be executed. Loops, the repetition of a set of instructions to tell the computer for the computer till a condition is met. Functions, the grouping of instructions to tell the computer what to do. And finally, data structures, a specialized means of organizing and storing data in computers. So why is C++ important? C++ is a general purpose programming language that is highly efficient and has low memory usage. For industry usage, C++ plays an important role in many contemporary systems, such as operating systems, web browsers, databases, applications, and etc. C++ can also be used in popular games like MapleStory or League of Legends, and is also found in aircrafts like F-16 and F-35. However, for you, the purpose of C++ might be different. C++ is a popular language used in competitive programming competitions like NOI or IOI due to its speed. Furthermore, C++ can be a useful skill for jobs in the future. Now, we'll teach you how to run C++ on your own device. First, let's get to know some definitions. The first one is compiler. This basically means that the program will translate whatever code you write. Because computers don't understand human language, the compiler will translate it to machine language. Normally, it's better to code and run C++ programs locally by downloading an IDE and compiler, but it's also possible to do so online. For this workshop, we won't be installing a compiler. Instead, we'll use an integrated development environment, or IDE for short. An IDE is a software application that provides comprehensive facilities to computer programmers for software development. IDE helps with syntax highlighting, autocomplete, and debugging. One popular IDE that you can use is VS Code. We will be using an online IDE called CodeCollab. I hope everyone has watched the video we've sent before the workshop, but it's okay if you haven't. I'll play the video again to show you how to sign up for CodeCollab. Oh my God. You can also use GitHub as an area to sign in, Google, or your Microsoft account to sign up for CodeCollab. Now, we'll give you some time to sign up for CodeCollab. Okay, so once you have signed up for CodeCollab, you'll be brought to this page, which shows the projects that you have made or the project shared with you. To create a project, you have to click on the plus sign at the top right-hand corner, which I have boxed up. A pop-up will appear, and in the first box, you have to choose the language for your project. For obvious reasons, my project will be using C++. Next, we have to name our project, and I just called it C++ for Newbies. And with that, we can create our project. After creating our project, we will be brought back to this page that shows you the projects that you have created or shared. On the right side of the projects, there are 3 dots. When you click on it, a menu of options will appear. And the second option is to share your project. By clicking on the share button, it will create a pop-out that has a link to share your project. Please submit this link to us via the Google form that we've put in the type pad so we can check if you're keeping up with us. This is the link. We'll give you some time to do it right now. The link is in the chat for you all. So when you click on your project, it'll bring you to this page. And on the left side of the page, there's a file called main.cpp. This is the file that you put your code in. On top, there are 2 icons. The left is to create a new file, while the right is to create a new folder so you can organize your files easily. On the bottom left, there's a button so you can increase the size of your font. And on the right, you can change the appearance of the theme. Once you've clicked on main.cpp, an editor will load in the box next to it. This is where you type your code in. Then, to run your code, you just have to click on the top right-hand button that's called Run. The output or input of the code will be displayed in the box to the right of the editor, called the console. This slide shows a code that asks the computer to print out hello, as seen by the output of the console. Now, I know the code won't make sense to you since we have not explained how to write C++ code. So with that, I'll pass the time to Ling Song, who will run through the syntax of C++.
All right, everyone. Hello. My name is Lim Song, and I will be teaching you guys about the basics of writing C++. So throughout this whole workshop, if you have any questions, feel free to just type it in the chat, and me and my team will answer you guys. So let's get started. Oops. Oh my God. Oops. Okay. Oh, sorry about that. All right, so to start out, this is our first line that we should have in our editor. Include bits/stdc++ dot h. We just okay. So what does this mean? What does this include mean? So what this is that it includes the libraries that your program might need when running C++. So what does that mean? You can think of libraries as like bookcases, and each bookcase holds books which contains a set of instructions that tells the computer what to do. And when you include a library, it's like you're telling the computer to look at a specific bookcase for the instructions, so that when you're running your code, it knows what to do. There are many includes in many different types of includes that you can have, but the one that you're using here, bits/stdc, is actually the most broad one because it includes most of the things that you need today, most of the code. And this is the first line. Don't worry if you don't have time to copy this because we'll be going through it together later on. Next line, on the second line, we will have using namespace std. So this is kind of similar to include in a way that it also tells the compiler they'll be using C++ standard library. So this standard library holds the basic C++ functions that you have. So as you guys follow along, feel free to just type in your code collect. Okay, so you can see here is our first two lines. And afterwards, we have our next three lines or the next few lines here. So the next line will be int main brackets. So don't worry, let's write this together in code collect. Oh, okay, give me a code collect. Let's write this together. So your first line, it will be the include bits/stdc ++ and your close. So that will be your first line. Your second line will be using namespace std. And remember to put your semicolon. What this semicolon does and how important it is, right? I will be going through it just later on. So just keep this in mind first. You have to include this semicolon. So these first two lines is the most important line of code. And you can have this for all your projects later on. You can have these two, which should be included in all your projects. Afterwards, you can see how I've included an empty line here. So this empty line is a personal preference of mine to include it so that I can separate out this with my main block of code. I think it just looks neater, but you can not have it, or you can have more if you want. So after this, we will write our next line, the int main. So what the main means is that this is the main block of code that you will look at when the code runs. So the compiler will look at this block of code first. And this is useful when you go into the later topic of functions, where you will see how that this naming of main is important. Right, so once you go to here, when you type in the curly brackets, just press enter, and the curly brackets will sort of like open up for you to type your code within this space. You also notice that there's an indentation that was automatically created. And then this indentation, you can create it by pressing tab. So when you press tab, it creates more indentations. And this helps you to organize your code. as you flow along, especially when you go into conditionals later on, where you can notice how indentation helps you to read your code better. So in this space between the curly brackets, this is where you write your code. So you can have multiple lines of code here, like this. Oh, cool. And you'll notice how at the end of each line here, I put a semicolon. So this semicolon is very important in C++ because it tells the compiler that this line of code has been executed and that it should start looking at the next one. So if you don't include this line of code, you realize that your error will pop up here. So it will tell you where it is. So it's quite an easy fix. So remember to always include your semicolons after each statement or each argument that you make. All right, so is everyone still keeping up? I'll give you guys some time to just copy this down, and you can ask any questions now if you want. Okay, so if you have any questions, you can just ask in the chat. My team will answer you, and we will be carry on now. Okay. So today I'll be going through the 4 basic syntaxes, and these are the most basic and ones that you will need to use. Okay, so the first one I'll be going through will be data types, followed by variables, inputs and output, and finally operators. So let's get started. Data types. I'll be going through the 6 main and most common data types here today, but in C++ there's actually more, but this is the basics here. So the first 3, let's look at it. The first one is integer, int. It is a 32-bit signed integer. And what does this 32-bit mean? It means that the maximum value that this data type can hold is around 2 billion. And signed just means that it can hold both positive and negative values. And lastly, integer, which just means that it's a whole number. So you can see on my examples here, I have 23, -4, and 5 million. Those are all integers. And this is a negative value in the integer. Next, I'll have a float. So a float is a number but with decimal places. And it's usually typically 7 dp. So you can look over here. This is a float because it has decimal places. And just like integers, it can also hold negative values. And lastly, you can notice my first here, 2.0. But 2.0 is 2, right? So what makes the difference between a float and an integer is this decimal place, this 0.0. So 2.0 is a float. However, just 2 alone will be an integer. Lastly, we have double. Double is just a more precise decimal. So it's a more precise float, as it typically holds 16 decimal places. So you can see something like this, where there's a lot of decimal places that usually float will not be able to hold all these. Float maybe will just cut off like here. So that is an integer, floats, and doubles. Next, we will have string. So the string is basically words and phrases, or can be combinations of characters. And it's usually enclosed by double quotes. So this. So what are some examples? You can see here. So hello. Hello is a word, and it's a combination of the alphabets like H, E, L, L, and O. So this is a string. You can also have 2 words, 3 words, a whole sentence, and this can be 1 string, like this hello world here. Or lastly, it can just be a random combination of characters and symbols. This is also a string. Next, we will have char, which is a character. So a char just holds only a single character, such as a single letter or a single symbol, and it's usually enclosed by single quotes here. So you can notice, for example, X is a single letter. So the data type of char, and is denoted by single quotes. Same for this N symbol, it's also single quote and it's a character. And lastly, you can see here, but it's an empty space, right? This empty space is actually a space, like your space bar, the space. And one space is actually also considered as a character. And lastly, we have Boolean, bool. So unlike strings and char, where you can hold like infinitely possible amounts of characters and strings, Boolean can only hold two values, either true or false. So unlike here where there's so many different ways we can enter a string, Boolean only has two, true or false. So up to now, I'll give you guys like 10 seconds to just digest anything. And if you have any questions, you can just feel free to ask. All right, okay, let's continue. So data types on its own is not that useful. It's in a way like a definition. And what definition, what does it define? It actually defines variables. So variables, kind of like in math, in algebra, you need to find the value of x in the math equations. Yeah, and then x can store like a value that you do not know. In C++, it's kind of similar in a way that variables in C++ can store values. But in C++, you can store more than just numbers. You can also store words and characters as well. So how do you use a variable? Now let's take a look at the first line here. This is a generic way of writing a variable. First, you include the data type. So this is a definition. You want to define the variable here. So data type, like the 6 that we went through, the integers, floats, double, Boolean, char, and string. And afterwards, you need to give the variable a name because you'll be using this variable throughout your code. So you want to give it a name so they can access the variable and the value that comes in the variable. So a variable name, you can be a single character, like X, Y, B, C. It can be a word or more characters like str, which stands for string. It can be like numbers if you want. And it can even be like 2 words and more, sort of like this, decimal points. But take note that if you want to have 2 words, you should use an underscore to denote a space instead of actually pressing space, because you want your name to be this whole thing. If you put a space, it kind of seems like your variable name is just this. So you want to put a underscore here so that this is like one string itself. All right. So optionally, you can include an initial value when you are declaring your variable. So like my line here, where I've declared the variable y with an integer. It's an integer and it has a value of 8. So this is the initial value that I declared. You can also don't need to declare if you want. You can don't declare, such as my first line here. I have not declared x to be any initial value. So x now has a null value. If you try to output x, like output what is inside x, the value of x, most compilers do automatically just put this as a 0, but not all of them. So just to make sure, if you want your x to be a 0, please do write equals to 0. And you'll notice that, you see, all the ends, the last of the sentences have all a semicolon. So this is very important in C++. I'll keep repeating this because it's very important. It basically tells that this is the statement and it's ended. When you're declaring it, that's the statement you're making to declare, and it's ended. And well, you see this tree here, I can just put in the initial value on its own. So I can just put in the number 8.123 and true on its own. But for characters and strings, you'll notice that in order to give the value, you have to put it in the quotes, the respective quotes. So let's say, look at the character here, char C. So the variable name C holds a character, and the character is X. So I need to put X inside single quotes. So similarly for string, if I want str to have a string, I have to put it in double quotes here. So this is, remember your quotations. And lastly, you can see on my last line here, why is there an error here? And that's because you cannot re-declare the data type of an already declared variable. So for example here, my y, I declared it as an integer. But I'm trying to give it a value of hello world, but this hello world is actually a string. And integer and string doesn't make sense because they are not the same thing. So this will just output an error. All right, so this is important to take note of. Okay, next. Let's say I want to declare many variables at once. I want to declare A, B, C, and D as all integers. I can write it like this. It is not wrong. It is correct. Okay, I can write it int A, int B, C, and D. But this takes up 4 lines, as you can tell, and it's quite a hassle to type, especially if you have to type int again, and again. So what if I tell you that you can actually shorten this code to just this? You can see how that both of them does the same thing. Both of them declares A, B, C, and D without giving an initial value. But I just shorten it by using commas. So I use int A, comma B, comma C, comma D. So this just shortens your code here to 1 line. And I think it looks neater that way. But one thing to take note of is that your A, B, C, and D have to be all integers. Like you will assign A, B, C, and D to be all integers when you do this. Okay. So now that we have variables, but how can we assign it values and how do we extract the values from it? So in other words, how do we input and output values from the variables? Well, we can input using cin and 2 right arrows. So how do we do this first? But before we can even input into a variable, you need to have the variable first. So you need to declare a variable like this here, int x, before you can write cin, 2 right arrows, and x. So the general way of writing this will be cin, 2 right arrows, and the variable name that you have already declared. So let's write this together. Okay. Write this together. So I want to input a variable. Okay, let's start. First, you must define a variable. Let's say I define variable x as an integer. And I want to input it. So I put cin, 2 right arrows into x, the name of the variable. And that's the way you input into a variable. So let's just give this a quick run. Oh, hold on, there's a issue here. Let me just quickly. Okay. 5. Okay, if you noticed, okay, let's go through what this output means, or this screen here, this console. What does this mean? So when I press 5, I press enter afterwards. So when I press enter, it essentially tells the code that I have finished inputting into X. So this line has been completed. And now, because this is the last line, the code has ended, which is what this actually means. This blue text just tells you that the code has finished running. And this test here, right, is actually the name of the project I have, which is test. So for you guys, if you name it differently, it will be a different name. But for my case where I have test, yeah, this is test. So this tells me that my code has finished running. And that is true because all I write there is to input into X, inputter. What if I want to input into multiple variables, such as maybe I have a A, a B. So I have 3 variables I want to input, all of them are integers. So what I can write is cin A, cin B. All right. So this is the way I can input. Let's just give this a run. Yeah, I press 5, I press enter. You notice that the code did not end. And that should be because I still have these 2 lines to go through. So when I press 5 and enter, once I press enter, the code knows that I've already finished inputting into X and I'll be looking at this line now. Okay, so let's continue. Let's say I want to input 1 now into B, 1 into A. I press space, And space does the same thing as an enter. When you press space, it also tells the code that you have inputted into A, and now you'll be looking at B. So let me now input into B, 2, and press enter, and C. Now the code has ended. So yes, when I press enter and I press space, it basically tells the code that I've already inputted into the respective variables. But you can see here, right, how I take 3 lines just to input 3 variables. You can also just shorten this as well. And how you can shorten this is to actually do it like this. So after your first variable, let's say on the input A afterwards, I can just put 2 more right arrows, A, the variable, another 2 more right arrows, and B. So in this line, I'm essentially doing the same thing as previously these 3 lines. So I can now just delete these 2. And you'll notice that this will look the same. This do the same as the 3 lines of Cins. So let me just give you an example. 5, 1, 2. There you go. It's the same thing because I've inputted 5 into X, 1 into A, and 2 into B. So that's one way you can also shorten your code for Cin. All right. So next, how do you now output a variable? Well, you can just use the cout, like Cin to input, cout to output. And the direction of the arrow is also flipped. So you can see now that I'm cout the value of X. So the value of X goes into the cout function to exit. So it will be 2 left arrows. And in this case, you can see out values of its own. So I can just, I can see out a variable here, and X is the variable with an integer and it's a value of 8. So I'm just outputting the value of X. And same for strings as well. My string has a value of hello world. And if I just output the variable name, you give me hello world. So this is your output, the simple output. You don't only have to see out variables. You can also just see out the thing that you want to see out. So like, suppose if I just want the number 8 come out to be the output, I can just see out 8, and that will be the output. Similarly, I can also see out characters, but if you want to do that, you have to make sure that you have the single quotes. So I am outputting C, which is the character that I've written here. You'll notice that all of these, I didn't have a variable because you don't need a variable to output. You can just output the thing you want to output, like right there. So same thing here for the string, for the word hello world, I can just output hello world. Okay. And let's take a look at this slide. Let's say I want to output multiple variables. So output X equals to 8. Output X and output hello world. So let's just write this together. Say I'll have a, let's say 20x equals to 8. And I want to cout X, cout. Let's say a word, a string hello world. Okay, I want to see this out. Now let's just give this a look. Oh, oops. As you can see here, I've forgotten my semicolon. And you see the error that pops out when the semicolon is not there. So yeah, you have to remember to put the semicolon. Just stop this, give it a run. Okay, so let's wait. There you go. This is the output. You'll notice that when I output X, which is 8, and I've outputted hello world here. But notice that 8 and hello world are together. And that's because cout doesn't give you a space or any like spacing in between. So if you want this to be separated, you have to output a space, like literally output a space. And a space is a character, so you have to put it between single quotes. So let's give this a run. And there you go, 8 hello world. And like Cin, where you can combine the inputs, you can also combine outputs. So instead of taking 3 lines, I can shorten this to just 1 line. So let's give this a look. Let's give this a try. Here, you can just combine. It's quite similar to how you can input. You have the 2 left arrows, and then your first output, then your 2 left arrows, your second output, 2 left arrows, your third output, and so on and so forth. Hello world. And I can just delete this first. And that will also give you the same output. There you go. Hello world is the same output. So that is also the same way as Cin, where you can shorten it. You can also shorten Cout like this. Okay. That is basically what I have on this slide. You can combine them together. All right. Now let's take a look at the next one. Okay, so sometimes we don't want the output to be on the same line. Like you can see on my first example where I just Cout hello world and I Cout new day, and they're on the same line. And I don't want that. Some questions maybe they want it to be on a new line, to be on right below this. So there's actually 2 ways you can do this here. The first way is to use 2 left arrows, then NL. This NL stands for end line. So basically it ends the line here, and your next output will be on a new line. So hello world NL. So your next output, which is new day, will be on a new line. And also you can also use this special character here, \n. And this character, what you want to do is to put it inside the double quote. So you can see my \n has actually created a new line here, which is why the blue text here is on a separate line as like compared to this, where the blue text is on the same line. This blue text is now on the second line, on the third line because of this \n. So before I continue, I'll give you guys about 10 seconds to digest this, and you can ask questions in the chat. All right, around 10 seconds has passed. Around 10 seconds has passed, so I will carry on to a practice. So there's a practice. Then you'll be using Cin and Cout for this practice. So let's take a look. What is the practice? I will input 2 strings, a name and a word. And then I want an expected output of something like this. So let's take a look at the context here. For example, I'll input 2 strings. So a name, John, and a word, hello. And I want the expected output to be the name said this colon, a new line, hello. So John said this colon, hello. So I want this to be the expected output. So I'll give you guys about 5 to 10 minutes to try this question out. And afterwards, I'll be typing the answer along. All right, guys, when you share your code, collab, right? Can you click this? Click share, right? Click what? Click link is enabled, and close this view only. When you do this, so that we can see. Yeah, so it can help you along as you code. So make sure that this is in the correct settings here. Okay, I'll just leave this on here. So make sure that it's correct setting. Okay, just a reminder, please uncheck your view only so that we can help you edit and test for you if you're having struggles. So remember to turn off view only and turn on link is enabled. Okay, this is important for us so they can help you. Else we don't have access and we cannot help you debug any issues that you have. Okay. So to display sharing window, you click this button here. No, sorry, this button up here. My bad. This button here. This is your share button. So this button here, your 5 icons here is the second one. This button here. You click on it, and that's where your share window is. And yeah, remember to enable link is enabled. Remember to check this box and uncheck this box. Make sure this box is empty. Remember that I want to be able to input the strings. So I want to input the name and the word. So sometimes I don't want to just have John. Maybe I want Tim here. Okay, so I want to be able to input the strings. This. Okay, and this output will be based on my input. So this John can change because this John, I want it to be a variable that can change. And this hello, I want it to be a variable that can change also. remember that I want my output to also include like this side comment here. Say this colon. Remember, I want this also. In your output, I want to have this, and these two should be able to be changeable. These two will be based on my input. So if you want to type out the console, if you want to do it correctly, your console, when you type John and hello, it should show this. If you need any reminder on how to use Cn and Cr, right? Let me just quickly type out a few things. So that's x. I have no value for x. Here is how you Cin. Just put this up for display if any of you needs it. Say, okay. Yeah, so if you need any reference, you can look at my my screen. You can see how you can use Cin and the direction of the arrows, or you can use Cout as well. And remember, this is how you can write Cin and Cout. Okay, so you can refer to this if you forget how the arrows or how to write it. You should look like this. Make sure, and this is not the answer, by the way. So this is not answer. So don't think that this is answer. This is just a reference for you. Oh yeah, okay. So one thing to take note of, right, is that in your code, there can only be one main function. So it only can be one with a main. Okay, because it's the main, right? It's the main block of code. It's the thing that your compiler looks at first. So if you have two mains, then it's not really the main anymore. So yeah, so make sure there's only one main. Here, it's like one main. If you guys need a reminder, if you want to declare a variable with a string, the string here is the data type. This is just the variable name. So this is the variable name. Okay. Variable name. And this itself is already a statement. So it should already end here. You shouldn't have like a cin right afterwards. You shouldn't give an initial value that you need to input. Don't do that. Instead, you should, if you want to input a value, do it on a new a separate line, a new line. So this is how you can input. I can declare a variable with a string data type. So remember, string is the data type. Okay, so if you have, okay, like me here, right? Yeah, I have here two C++ files here. This is for the later on when Gabriel takes over. But if I have two here and I want to just run the main one, what you do is to right click, you have this drop down option, click compile this file. So you give an update successfully. So what this means is just that now the compiler will just look at this file here, not this second file. So if you want to switch, you have to just, every time you have to compile this file if you want to switch. All right. Most of you have seem to got the answer, but let's just go through together. So let's go through the question again. I will input two strings. So automatically you will know that first thing first, you need to have two strings. And you will need to be able to input into them. So you need to use the cin function. And after that, I have an expected output here. So now you know that you also need to have output. So let's do this question together. Okay, let me just clear this. So just follow along. First thing first, I know that I need strings. My data type will be a string. So string, this is my data type. Next, I want two strings. So I need two variables. And conveniently, the variable name that I can use is here. So my first variable shall be called name. And my second variable shall be called word. So the name and then the word. And your semicolon. Remember the semicolon, not a colon, but a semi-one with a comma, dot and a comma. After this, I want to input the values into the variable. So cin, two right arrows into the name. So now my input is the name, and again into word. So now I can input two times here. The first time I go to name, the second time I go to word. And now, of course, a semicolon at the end. And now let's take a look at what the output wants. The output wants John said this, colon. Okay, let's just look at this first line. The name said this, colon. So see out, because you want to output now, output your name. So your two left arrows. Okay, and your variable name is your name, the name. And now the output said this. Okay, so you notice how I put a space here. There's a space between my said, before my said, there's a space. And that's because if I don't put a space here, then this space doesn't exist. And your John and your said will be together. So I have put a space here. So said this. And notice how I want my hello to be on a new line. So I, and L, and I, semicolon, and L, and I, semicolon. So this one C out will be your first line. John said this, semicolon. So name said this, colon. Yeah. And that's not done. I'm not done yet. I still got the second line of output. Hello. So now I can see out my word. So let's take a look at this and let's run this. Wait for my files to load in. Go. So name John. And now when I press enter, I have cin, I've inputted John into the name, which is my variable. And next I have hello. If I press enter, hello has been inputted into this word, the variable word. And now, because my word, my name holds a value of John, your output John. So this is your name, John. Then your space, said this, colon, space, said this, colon. So this will output because of this. Your NL, that's why this is on a new line. And finally, your word, hello. So this is your word. All right, is everyone clear? I'll just leave this up on the screen for a few more seconds so that you can look through it and digest. Remember the direction of the arrow. Cin is to two right arrows. Cout is to two left arrows. You can think of it like a inputting, like, you know, you take a value from here and you go into the variable, like into. So you can think of it like going into the variable. And for output, you can think of the value going from the variable out of the variable, like going out of the variable. So that's how you can remember the direction of the arrows. So remember cin into the variable. So it's two right arrows. Cout out of the variable. So it's two left arrows. So just take a look at this, slowly digest. All right, I hope everyone is able to digest this. You can take a picture, you can copy this down so they can refer it. But don't worry, we will post all of this onto our GitHub after the workshop. So we will send you guys the link after the workshop. And we'll put all this up so that you can refer to it afterwards. And the video is recorded. This Zoom meeting is recorded and will be posted on YouTube if I'm not wrong. So you can also refer to that. Okay, so let's continue. Operators. So, like in math, operators like your plus, minus, times, and divide. Give me a moment there. Oops. Your plus, minus, times, and divide. So your operators is quite similar in the way that it can manipulate different variables. All right, so you can manipulate like the x and y that you see just now. You can add them together. So we'll continue to go through this as I go along. And it's usually only between two variables of the same data type. So basically, usually it's an integer with an integer or a string with a string. So it shouldn't manipulate between two of different types. Although there are some like unique circumstances to this and this point, and we will go through that later on as we carry on. So let's begin. So there are 5 main operators here that we will be using: an addition, subtraction, multiplication, division, and lastly, remainder, also known as modulo. Okay, so this, like an example here, 5 plus 2 is 7, 5 minus 2 is 3, 5 times 2 is 10, 5 divided by 2 is actually 2.5. But you'll notice why I put 2 here later on as we go through this, go through the data types for inputs and answers. Okay, we take note of this first. You'll notice why you not this 2 and not 2.5. And lastly, remainder, where 5 divided by 2 is 2 and has a remainder of 1. So 5 remainder 2 is just 1. Okay. Next, there is also some short forms that you can use. So for example, plus plus and minus minus. So what this does is that it adds or subtract 1 to the variable. So like this, x plus plus means that x is equals to x plus 1. You might think that this doesn't make sense mathematically. And you are right, it actually doesn't make sense at all in math. Because if you bring x over 0 equals to 1, it doesn't make sense. But this is not math, so this is C++. So what we are actually doing here is that we are redefining what x is using the old value of x. So for example, let's say that x is equals to 5. Okay, x is equals to 5. What it does here is that we are redefining the value of x to be the old value of x, 5, plus 1. So now x becomes 6. Because the old x is now 5 plus 1 is equals to 6. So same thing for minus minus, x is equals to x minus 1. So let's just take a look at how it works in the code. Okay. Let's say I have an integer x equals to 5. And I perform the function, forget my semicolon. I perform the function x plus plus, semicolon. And lastly, I want to output the value of x. So let's give this a run. And if it comes up, yeah, 6, because now I have added an extra value to my x. I added 1 to my x. If I put minus minus, run this, and give it a moment. There you go, 4. I have now subtracted a value from x. And this is the same as plus x equals to x plus 1. There is x plus plus is the same as this. If I give it a run, there you go, 6, because x 5 plus 1 equals to 6. Now we look at the second one here. plus equals, minus equals, times equals, divide equals. So what is the difference between this and this? Is that this adds and subtract 1. Whereas you can add, subtract, multiply, divide a certain value to the variable. So let's take a look here on my first line. X plus equals to 5 means that X is equal to X plus 5. Okay, notice how this is different from here because I have set my increment, my addition to be a 5. So X plus 5 as compared to X plus plus, where it's just plus 1. So this is the same for all the 4 operators. This you can see here. And lastly, we have this is the 2 /. Okay. What this actually means is a comment. You'll notice that when you were doing the practice, where we were giving you comments, we use this. And this is because this symbol basically hides the line that we are writing the comment on. And the compiler will not see and execute that line. So let's give it a try. Anti-X. Let's say I want to make this invisible to the compiler. I can put 2 slashes. And you'll notice how the code has grayed out. And that's because this is technically, to the compiler's eyes, doesn't exist anymore. So if you run this, 5. That's because this code doesn't exist to the compiler. So now it just thinks that X is equal to 5. So when it's outputting X, it's outputting 5. This is very useful in cases where you want to make comments to yourself, or maybe for your future self, if you ever look at the code, it can be like, this means X plus plus. So this is basically a way for you to read your code, especially like in the future when you come back to it and you're confused. You can use this to define or to like make a comment on your code. And that's how we have been doing, making comments on your code as well during your practice. Okay, so this is comment. Before I carry on, is there any questions? I'll give you like 10 seconds to digest this. Okay, let's continue. Remember how previously I have remember previously how I have talked about me not using operators on different data types. Well, you realize that I can actually use operators on slightly different data types, such as this. Float y equals to 2.5. Int and float are different data types, but they are very similar in the way that they hold numbers. And because of that, operations do work between both of them. So if I were to do an x, if I were to just see out x plus y, can you see what my output will be? X plus y, even though they are different. Oh no, I have forgotten my semicolon again. It's okay. It's an error that is very easy to fix. All right, let's take a look. There you go, 7.5. And that's because when I add x plus y, even though x is an integer, y is a float. So this operation will become a float. It will take on the float data type here. And that is why x plus y is equals to 7.5. But let's do something a bit different here. Let's make both of them integers. You remember my previous example? Let me just bring it up again. Just bring it up. There you go. You notice how I put here 5 divided by 2 becomes 2. Well, let me show you why this is so. 5 and 2 are integers. Both of them are integers. If I take x divided by y, most people think that, oh, you get 2.5 because, well, that is what 5 divided by 2 is. But let me run this code and show you. 2. It comes out of 2. Why? And that's because both x and y are integers. Unlike the previous example where I gave you a float y, so let me just float y. Okay, unlike this example where it's a float, I give you an integer instead. So there's no float at all in this x divided by y. So the value of x divided by y will automatically take on a float, an integer data type. Because both of them are integers. So x divided by y will be an integer. And what does integer do? An integer takes, your integer will just delete this 0.5, will delete anything with a decimal place, will just delete. And that is why your output is a 2 and not 2.5. I can show you the difference again. Oh, I can show you the difference again. Let me just remove these comments. You see how I use the float now? Let me run. There you go, 2.5. As you can see, because my y is a float, and I were to take x divided by y, you automatically become a float. So this is important, all right? When you want to divide or some different operators. Okay, so let's carry on. You don't need to use operators for only numbers. You can also use operators between strings. For example, in this example here, I have 3 strings, S1, S2, and S3. Remember, string is the data type that you type into it. Okay, so S1 is hello, S2 is world, and I want to sum it up. I want to make it hello world. What I can do is to just take S1 plus a space. Remember, the space is important because there's no spaces here. If you don't include a space, then your hello world will be connected. So S1 plus a space plus S2 and your semicolons. And that will give you hello world. So that's your S3 become hello world. Then you can use your operations here. All right. So let's carry on to the next practice. Okay, this practice, I want you guys to make a division calculator. I will input 2 numbers. And I want you guys to perform a division operation and output a float. So in this case, I'll input 5 and 3. And I want you guys to give me a float. So 5 divided by 3, which is 1.66667. So yeah, I'll input 2 numbers and you have to perform a division operation. So okay, I'll give you guys around 5 to 10 minutes or so to try this, and I'll go through the answers afterwards. If you have any questions, just type in the chat as well. Okay, so I'll be going through the answer now. So let's take a look. Let's write the answer together. Okay, so first thing first, let's look at the question. I want to input two numbers, 5 and 3. Most people would think that, oh, two numbers, 5 and 3 are whole numbers, so let me use integer. But remember what I said just now, when you just take an integer divided by integer, the output will still be an integer. Okay, I'll explain the error more, but let's just go through the correct answer first. So because of that, because I want my output to be a float, at least one of them needs to be a float. But in this case, I can put both of them a float at once. So let me give you a float. Let's say my first number is x. My second number is y. So now I have declared my first two numbers that I want to input. So now I want to input it. To input, remember, is cin, two right arrows into x, two right arrows again into y. There you go. So now I have this code will now allow me to input into the variable x and into the variable y. And I can now see out. I can just directly do the operation right at my output. See out x divided by y. So let's take a look at the let's run this code. Remember, your see out is two left arrows, x divided by y, the value of this, into see out. So let's give it a try. 5, 3. Yep, 1.6867. That is the correct answer. Some of you may do this instead. Some of you may do this. Let me show you what. This is not correct, by the way, but let me just do this so you can learn. Oh, give this, so x equals to. Okay, let's take a look at what the answer will come out first. Okay, let's take a look. 5. Oh, hold on a second. Oh, my bad. I made a mistype. Sorry. Okay, let's do it again. Oh, again, my bad. Take a look. Okay, 5, 3. It just may give me 1. Why does it just give me 1? I define z as the float. I define z as a float. So why does it just give me 1? And that's because your x and y is already an integer. It has already round down the value of x divided by y. So even if you put it into a float, x plus y, the operation will do it first, will already make it integer, which is why your x divided by y is 1, and even though your z is a float, it will still be a 1. So this is the wrong way of doing. What you should do is to make sure that your inputs, at least one of them is a float. So this is also a correct answer here. So up to now, is there any more questions? I'll give you guys a 5 minutes break. So you can take this time to drink water, right, or go toilet, or if you have any more questions, you can just ask them in the chat now. Okay, guys. Hello, guys. My name is Aika, and I'll be taking over Lingsong for this portion of the presentation. All right. So hope you guys had a good break. Hope you guys are more familiar with how to use code collab. Right. So now I'll be taking you through conditionals. Okay. So first, what are conditionals? Right. So the root word for conditionals is just condition, right? So conditions, I'm sure we use in everyday life. For example, I will only go outside if it's not raining, right? I will only run if it's not so hot, right? So these are considered conditions. Okay. So before I show you how to implement these conditions to C++, let's go through some basic operators that we're going to use. Okay. So first, we have double equals. So this double equal sign is the means is equals to or is equivalent to. Okay. So let's take a look at this example over here. So here we have 5 plus 3 double equals 10 minus 2. Okay, so what does this mean, right? So this means this is basically asking the computer, is 5 plus 3 equivalent to 10 minus 2, right? 5 plus 3 is 8, 10 minus 2 is 8. So this is asking the computer, is 8 equivalent to 8? Okay, so obviously they are equal. So hence, this will return true because this is correct, right? So for the next two, we have more than equals, less than equals. So for those of you who know some basic maths, you should be familiar with these signs, more than equals to and less than equals to. So for maths, we usually just put a single line below these signs, but for C++, we put an equals, right, on the right side of it to denote more than or less than or equals to. Okay, so let's look at this example. All right, first we have 10 times 2 more than equals 3. Right, what does this mean? The same as before. It's asking the computer, is 10 times 2 more than or equals 3? Right, is 20 more than or equals to 3? So since 20 is more than or equals to 3, this will return true. So I'll get a true from this. All right, similarly, for the next one, we have, is 4 times 5 less than 7? Right, is 20 less than 7? So since that is wrong, I'll get false. Okay, so for the last one for this slide, we have exclamation mark equals. So what this means is not equals to, which is the opposite of what we went through at the start. Okay, this is not equals to, at the start is equals to. Okay, so here we have 2 times 5 not equals to 10. All right, so this is saying, is 10 not equals to 10? Now, if you think about it, 10 is equals to 10, right? So if 10 is equals to 10, but this is saying not equals to, so is 10 not equals to 10? That should be false, right? Since 10 equals to 10. And yes, we have a false output. And it's also very important to note that all of these outputs are Boolean values, right? As Lingsong has mentioned earlier, Boolean values are either true or false, yes or no. Only 2 values, right? Okay, so I hope you guys are clear with this. If you are not clear, please ask in the chat and my team will help you gladly, all right? So next, we have something called logical operators, right? The AND operator and OR operator, all right? So the AND operator is denoted by these 2 symbols over here, the AND symbols, right? And they give the answer true if both of the events are true, meaning the left, all right, meaning 2 expressions and conditions return true. So what do I mean by this, right? Okay, let's take a look at this example on the right. We have a long line of code here. So don't be scared by this, okay? Because I'll break it down for you. So similar to maths, there are brackets here, and whatever in the brackets come first, right? So now we see 2 conditions, okay? These conditions we have went through in the previous slide. These conditions are enclosed by brackets and are put around the AND operator. Okay, so let's break it down, all right? So first, we see, is 1 plus 1 equivalent to 2? Correct, right? So this is correct. So now we look at the next bracket. is 2 plus 3 not equals to 4? Right, so since 2 plus 2 equivalent to 2, so this is correct. And since 2 plus 3, 5, which is not equal to 4, this is correct. Since both of these are correct, the whole thing will output true. All right. Since the left condition and the right condition is correct, as said in a definition, both have to be true. And then the final one, it is true. All right. So next, for next we have, is 2 plus 3 equal to 5? Yes. So this is correct. Is 5 minus 2 more than 5? So 5 minus 2 is 3. Is 3 more than 5? No. So 1 is correct and 1 is wrong. So what do you think this output will be? False, right? Since for n, both have to be true in order for the total output to be true. But since in this case, only one is true and 1 is wrong, hence the total output is false. All right, I hope that's clear. So secondly, let's go through OR, the OR operator, right? This OR operator gives true if at least one of the events are true. So this is different than AND because OR only requires one event to be true. So the OR operator is used using the two vertical bar symbols like this. All right. So let's look at examples, okay? So as you can see here, similar, we look at the brackets first, okay? So is 5 times 2 more than 4? Is 10 more than 4? Yes. So this is correct. What about this? Is 2 plus 1 equivalent to 3? Yes. So since both are correct, similar to AND, the final output is true. Okay. Let's look at the next one. All right. Oh, is 5 times 2 equivalent to 4? No, right? So this is wrong. Is 5 plus 5 equivalent to 10? Yes. So in this case, 1 is wrong, 1 is correct. So what do you think the output will be based on the definition? True, right? So this is what makes OR different than AND. Because for AND, if 1 is wrong, 1 is correct, the output is false. But for OR, if 1 is correct, as long as 1 is correct, the output will be true. Okay, I hope this is clear. Any questions, please ask in the chat. All right, so now we have these conditions, right? Oh yeah, sorry. Also to mention, these are Boolean values, so they have to be yes or no. Yes, true or false. Very important. All right, so how are we going to use these conditions, right? So we use something called if statements. Okay, if statements. Okay, so this is the syntax for if statements, and these conditions have to be Boolean. Right? I'm going to emphasize this a lot because this is very important. Yes or no, true or false. So for example, if it is raining, right? If it's raining, I'll bring an umbrella, right? If your math score is more than 50, yeah, just tell your mom you passed, right? But if your math score is not so good, you know, the dog ate your work, right? Of course. So yeah, so this is how we write if statements. Okay, let's try it out. Okay, so let's say we have an integer n, and let's declare it as 50. Okay, our score, right? Let's make it, you know, more contextual. Let's say we scored 70 on the test. Okay, so I want to check if I passed. So if score more than 50, all right, then it'll tell me that I passed, right? Right? Don't forget semicolons, okay? So, all right. So if my score is more than 50, I passed, all right? Let's run this, okay? Let's check. Okay. Yes, look, as you can see here, I passed. Right, now let's change the score. Let's see what happens, okay? Let's say I get 20, all right? Let's run. What's gonna happen? As you can see, nothing has been output because my score did not meet this criteria. So my score is 20. So the computer asks, is 20 more than 50? So since that is wrong, it will completely ignore whatever's here and move on with the code. All right. I'll make it more clear. Let's try this. So n, all right. Let's try this again, all right? Look. As you can see here, there's no past and only the end. So this clearly shows that since 20 is not more than 50, this whole thing is ignored and it goes straight to the end after the if statements. Okay, I hope this is clear. Moving on. So now we're done with the basic if statements. I have to ensure that all of these are also Boolean values. Okay, I have to be very sure. So now we're done with if statements. I want to introduce you to else, right? If and else. So also these have to be Boolean, and else, the basic concept of else is very simple. It's basically is the opposite of the conditions that are above it. All right. So if this is true, this is false. If this is false, this is true. What do I mean by this? All right, let's show some examples. So if it is raining, it is true. If it's not, I don't need an umbrella, right? So if it's raining, I'll come here. If it's not raining, I'll come here, right? So if it is raining, then I would just do this. I wouldn't have to do this, right? But if it's not raining, I'll just ignore this and come here, all right? Similarly, if your math score is more than 50, tell mom you passed. If it's not, yeah, the dog ate your work, right? Okay, so let's put in this context, all right? So let's put in else here, all right? Else here, all right? See out. Failed, all right? So what this is saying is that if my score does not meet this, so this now is 20, since 20, so the computer is asking, is 20 more than 50? No, right? That's false. So it will not read this line and it will immediately jump here, right? Let's test this out. Let's add and line, right, like that, right? Okay, let's test this out, all right? As you can see, it successfully put failed, right? Because it ignored this line and went straight here. Right now, let's try with another number. So now we passed, right? So let's show you. I'll show you. So now, look, now it says passed without saying failed, right? This is because 70 is more than 50. So it will just read this and it will ignore all of this, right? Hope that's clear. Please, I want you guys to type along with me so that you guys can be more familiar with how to write it and like the syntax, and my team and I will help you if you have any issues, because we are thoroughly looking through your code and trying to help you guys along the way. So please practice along, right? So now that we're done with this part, yeah, we have to ensure that they're all Boolean values, okay? So now I want to ask you this question. What's the difference between these two? Why can't I just write this? Why do I need else, right? Because if you think about it, these two actually do the same thing, right? Because they're just the opposite of one another, right? Well, let's see how the computer runs this, how the computer processes this, okay? So first, the computer is going to check, oh, is it raining? So if it's raining, it's true, right? If it's raining, just do this. However, since there's another if statement here, the computer is going to read this again, but it doesn't have to. It's redundant because you already checked, correct? So by reading this again, it's just additional work for the computer, right? As compared to the right side. So once they check if this is true, so if it is raining, just bring an umbrella. So after that, as I mentioned, you'll skip all the way to the end and you won't even look at the else part. All right, hope that's clear. So why would I choose to use one over the other? Well, first, obviously, there's a less redundant code and reducing unnecessary processing. But to be honest, it doesn't really make that much of a difference in terms of speed because it's very minor. But overall, it just looks neater, all right? To make your code look cleaner, right? So let's practice now, right? I want you guys to take an integer x, okay? Input x, okay? So I want you guys to output true if the integer is even, and output false if the integer is odd. Okay, so some hints. Yeah, we can recap. We use a cin to get the input, cout to get the output. Yeah, that's quite straightforward. But how do we want to determine whether or not it is even or odd? All right. So this is where some mathematics have to come in, right? So I want you guys to try using x%2 equals to 0 to check if it's even. All right, but why? Why does this work? Okay, so I want you guys to recall what does the percent operation mean? Okay, I want you to recall what the percent operation means. All right, try to remember. Right, so let's get you guys started. So let's say I have an int x, right? Then I want to see in x, right? And then I want to check if yes, x%2 equals to 0. Now, why does this work? Why does this work? Right? So maybe you guys can take a few minutes to try this out and experiment on how to determine whether an integer is divisible by 2. Integer is an even number, right? So let's give you guys a 1 to 2 minutes to try to play around, and then I'll explain when we get back. All right. Please practice along. It's very good to get typing, get familiar with how you actually write. And please ask questions, because this chapter can be very confusing. So please clarify all your doubts and I'll be happy to help. All right, guys, hope you guys have explored. I think you guys have explored how does this work and how why it works, right? So let's recall, what does the percentage operation does? What does it do? All right, sorry. So percent operation is called modulo, which means it returns the remainder. All right. So what does this say? x%2 equivalent to 0. Right. So this means if x divided by 2 and the remainder is equivalent to 0, right? So if the remainder when x is divided by 2 is 0, it means that it is an even number, right? Because all even numbers are multiples of 2. I hope you're catching up. If a number divides by 2 and there's a remainder of 0, means that is an even number, right? So hence this will work, because x%2 is to find the remainder when x is divided by 2. So since x divided by 2, if it's equivalent to 0, it means it is an even number. So hence, I'll output true. And then else, output false. Because if a number and it divides by 2 and there's a remainder, it obviously means straight away that it is not an even number, right? Because all even numbers, if you divide by 2, it will have a remainder of 0. Right? So hence this will work. Since the remainder is the remainder of x equals to 0. If it is true, we'll output true. If it's not, output false. Right? Let's give it a try, right? So let's take 10. 10 is an even number, right? So yes, output true. All right, let's give another try, right? Let's say 7, right? 7, when you divide 7 by 2, there is a remainder of 1, right? So hence, it's not equal to 0, and thus it's false. Okay? So hope you guys are clear with this. All the example problems will be uploaded to our GitHub, as mentioned by Lingsong, and uploaded at the end of the workshop.
All right, so take a few seconds to copy this if you guys need. All right. Okay, I'll go back to the slides in 3, 2, 1. Okay. All right. So moving on. So what if, right? What if there are multiple continuous conditions, right? You want to check multiple things. You don't only want to check if it's raining or if it's not raining. You want to check if it's raining, and if it's raining, what else do you want to check, right? For example, let's look at this flow chart over here. So if it's not raining, you cycle to school, right? If it is raining, however, you want to ask yourself, do you have enough money, right? And if you don't have enough money, just take a public transport. If you do, take taxi to school, right? So this green line highlighted over here is the continuous condition that I'm talking about, right? You want to check two things, right? So let's take a look at this. Now, I want to introduce you to something called else-if statements, all right? So this is the syntax, all right, okay. Ensure that you have your curly brackets, okay? And also ensure that these two conditions have to be Boolean, Boolean 1 and Boolean 2, okay? So let's implement that flowchart into this code over here. Let's take a look at this. So if it's raining equals to false, means it's not raining, then we cycle to school. If not, all right, if not, then we check if we have enough money, okay? So only when this is false, only when it's raining equals to true, and then we check if we have none. That's why we have an else if, right? Else if, right? If this is false, and then we check if we have enough money, okay? If we have enough money, it's true, we take a taxi. Else, we take the bus. All right, as I said, else, okay. Else is like the last resort, okay? If everything above it doesn't run, all your conditions do not meet everything above it, else is the last resort, right? Else, if everything doesn't work, the code will run to else, okay? So if it is raining and if you don't have money, else, last resort, take the bus to school. Okay, I hope this is clear. Please clarify if I'm not clear, and please ask questions, because this is a very important, really important skill that you guys need to understand. Oh yes, also, someone asked in the chat about elif. Elif is the shortened for else if, but elif is for Python and it's not for C++, right? But the idea is still the same, okay? All right, so moving on. Now let's look at something even more extensive, all right? We're going to look at more if statements, okay? So, is it raining? If it's not raining, we cycle to school. However, if it is raining, we check, are you late for school? If you're not late, just take a public transport to school, right? However, if you are late, do you have enough money? If you have enough money, you can take a taxi, right? If you don't have enough money, maybe your parents have a car, right? Are your parents busy? If they're not busy, you can ask them to send you to school, right? However, if you're busy, just cry and take public transport, because you probably end up in detention, right, for being late. So, all right, so now we have 3 highlighted lines over here. So this is the more extensive, all right, more extensive conditions that I was talking about earlier. All right, so for these types of extensive conditions, we want to use something called nested if. Right, so what does nested if mean? Nested if basically means it's a smaller if statement within a larger if statement. All right, I'll illustrate what that means in a while. All right, so let's take a look at this flowchart on the right. Okay, this is the flowchart that we were going through earlier. All right, so first we're going to check if it's raining, right? Is it raining, right? If it's false, yeah, then we go to this path, we cycle to school. If it's true, else if, right? Else meaning this is not true, and then if we want to check if we're late for school, if that is true, then we want look. So once we check if it's true, we go to this diamond over here. So now we want to check. So if we are late for school, we want to check if we have enough money, right? So now, what do we have here? As you can see, we have an if statement inside a larger if statement, right?
So this is what I mean by nested if, right? It's a smaller if statement nested within a larger if statement. Okay. So now we're gonna check if enough money equals true. So if we do it, if we have enough money, take a taxi, right? If we don't have enough money, we want to check if our parents are busy. So if our parents are busy, yeah, we return true. If our parents are busy, yeah, this client take public transport, right? So if our parents are not busy, so there'll be else, right? Because else means the last resort, means parents are not busy. Parents are not busy and you don't have enough money, right? So it's the opposite of these two. Is the last resort, right? If these two don't pass, they'll go to else. Okay. Then ask your parents to send you to school. All right. So now it may look like we're done since we reached else, right? Like I said, else is the last resort. However, else is only the last resort for its current if statement. All right. As you can see, else here is referring to this blue if statement over here. But what about the red statement, right? And evidently, as you've seen in the flowchart, there's one unhighlighted portion over here. So now, since we have accounted for every possibility if we are late for school, now let's think about what if we are not late for school, which is the else for this part over here, right? So else, we just take public transport. So as you can see here, this else is referring to this larger red color if statement, but this small else is referring to this smaller nested if statement. All right, I hope this is clear. So this is the idea of nested if statements, right? There's a smaller if statement within a larger if statement, right? This is to help with more extensive checking and more extensive decision making, right? So you want to check is it raining? You want to check, am I late for school? You want to check, do I have enough money? Are your parents busy? Etc. Right? That is very extensive, and you can have even more nested ifs, right? So, all right, so I'm gonna move on from this. So yeah, so now let's put that into application. Okay. Oh, I'm not going too fast. If I am, please tell me to slow down, and I'll try my best to explain it to you guys better. All right. So let's take, for example, a test. Okay, now you have a test. So I want you guys to take in an integer s and output the corresponding grade with the score. I want you guys to take a look at this this grading system over here, right? So let's say my score is 95, right? My score is 95, then I'll get an A star, obviously, right? Because 95 is between 90 and 100. Okay? So let's say if I get 60, right? My score is B because it's between 60 and 69, inclusive, obviously. If I get 49, all right? 49, I'll get an F, fail, right? Because it's between 0 and 49, inclusive. Okay, so this may sound easy to the human brain, but how do we translate this into something that computer can understand? All right, so let's take a step back. Let's break it down, right? So how do we want to make this so the computer can understand, right? So first, we want to think of it how to express it mathematically, right? Because the computer likes maths, you know, it doesn't understand English, it likes maths. So we need to think about how can we use operations that we have learned to express it mathematically. Okay, so first, let's our variable is s, our score is s, right? So we want to check if s is between two numbers, right? Because that's the condition, that's the determining factor of our grade, right? If it's between two specific numbers. So let's say if s is between 90 and 100, I'll get A star, right? So how do we express that? So it's fairly simple. We use the inequality sign, right? We do in maths, this is a very common as s is more than equal to 90 and s is less than equal to 100. So this means that s is in between 90 and 100, right? Okay, so for the next one, it's the same thing for the next one. However, for this, I put 2 because both of these work. You can use that interchangeably, right? The reason why is because, as you can see, these two signs over here, they're different, right? One includes 90, one excludes 90. Sorry, one includes 89 and one excludes 90. So both has the ending limit of 89. Okay, I hope that's clear. And same with the others, right? The same thing, inequalities. All right. So now once we got that down, once we got that inequality, right? But so this is technically logical, right? But C++ doesn't understand this. It doesn't understand because this is too complex for C++, right? So how do we even break it down even further, right? So let's think about it. So S has to be between 90 and 100, right? So it technically has to be more than 90 and less than 100. Does this sound familiar? We can use the AND operation, right? So as I said, we look at the brackets first. Is S more than or equals to 90? And is S less than or equals to 100? So this is a broken down version of this, right? The right side is the broken down version of the left side. Same with the others, right? So it's basically checking, is S in between these two numbers? Okay. Hope that's clear. Please slow me down and please ask if you have any questions. All right. So I'll move on from this. Okay. So this is a sample flowchart of this problem, this practice that you guys can try out. You guys don't have to follow this flowchart. It's just an example, and it's useful for you to illustrate how you're going to plan out your if statements. Okay. So I'll give you guys about 5 to 10 minutes, maybe 8 minutes, 6 to 7, I don't know, around there to try to do this code, right? And please ask if you have any questions, because this is very important. It's a very important concept to grasp and to understand, all right? So yeah, you guys go practice now, and I'll talk to you guys soon. All right, I see you guys have, some of you guys have not trying to practice. I encourage you to practice because this is very important. If you guys are lost, please ask questions and please just type in the chat, or you can voice out. Okay, guys, maybe I can start you guys off on how to tackle this, all right? Because some of you seem a bit lost. So it's fine. So it can be a bit hard. So let's take a look at this. So if our score is, as I said, more than equals to 90, and score less than equals to 100, right? Right. So now, since it's 90, then we can, print output, right? And then, but if it's not, right, then, right, there's else if And then if it's not, else if your code, and then it's not, else if, and then yo. Is it good? All right, sorry about that. Damn. Yeah, all right. So can everybody hear me and see me? Sure. All right, okay. Okay, so yeah, so this is the template you guys can use to help you get started. So don't be too let back if you can't really solve this question quite yet, because I understand this can be a very hard topic to grasp. So I'll give you guys a couple more minutes to try it out and to explore and to see to explore your coding style, right? Okay. Okay. No. Shit. Please ask questions in the chat. My team and I will be glad to help you. All right. Don't give up. All right. We're almost there. 1 more minute and then I'll go through the answers. Okay. Okay, guys, so now I'll go through the suggested solution. Of course, there are many ways to do this, but I'll go through the suggested solution, all right? So to start off, all right, so now we have the first condition correct, right? So now this will check if our score is more than or equals to 90, is in between 90 and 100, right? So in that case, we see out the score, which is a star, right? And else if it's not, right? We're gonna check if it's in between 70 and s less than or equals to 79. Hold up, 89, sorry. Yes. And then if this is true, hey, all right, and this is still not true, let's check some more. If s is more than or equals to 60 and s less than or equals 69. All right. Oh, all right. Yeah. Here we go. And then I'll put B. But if it's still not correct, so let's try again. More than or equals to 50 and s less than or equals to 59. Please try to practice along with me so that you guys can be more familiar with it, and you guys can eventually get it, right? So now C out C. All right, but however, as you can see in the flowchart, C is the last grade if you have a score, right? So the last result is F, right? If it's not A star, if it's not A, if it's not B, if it's not C, the last result has to be F. So therefore, instead of putting another else if, I will put else, right? Therefore, this is the code, right? Let's give it a run. Okay. All right. So let's say I get 60, 65, right? Yeah, look, I got a B, right? Because it does not meet this criteria, so it checks this. Does not meet this criteria, so it checks this. Oh, it does meet the criteria. I will output this and ignore everything below it. Okay. All right. So let's try again. Now let's say I get 55, right? Sorry, I get 55. Okay, and I get C. Why? Because if my score is 55. I check this, not true. I check this, not true. I check this, not true. I check this. Oh, it is true. 55 is more than 50 and 55 is less than 59. So I output this and I ignore everything else below it. All right, I hope that's clear. As mentioned earlier, this code will be uploaded to our GitHub at the end of our workshop. Okay, so you guys can revise and study on your own time. Okay, so now that we're done with conditionals, let's move on to something more interesting. All right, time to talk about loops. Okay, so first, what are loops? All right, loops allow us to repeatedly execute a block of statements until a given condition is met. What does this mean? Basically means I want to tell the computer to do something over and over again until I tell it to stop. Okay. So why do we need loops? All right. So for example, I want to count I want to know all the numbers. I want the computer to output all the numbers from 1 to 10. Right. So it may seem simple. Some of you may suggest this, right? We can just output all the numbers from 1 to 10. Just write it like that, right? But what if I say I want all the numbers from 1 to 100 or 1,000 or 1 million? Are we expected to write every single number that is all the way to the number we want? No. So this is very inefficient. So hence we need loop to process this repeated process over and over again for us, so we don't have to, right? So for loops, there are two types of loops: while loops and for loops. These are very important, and these are the main type of loops that all programmers should be comfortable with. Okay. First, let's start with while loop. So while loop, the syntax is fairly simple. While a condition is met, while a condition is true, I will do something, right? And this condition has to be a Boolean value. Okay. So let's try something. So let's say like the previous example, let's say I have counter. I want to count all the numbers from 1 to 10, right? So let's have a counter, right? Because I want to know where I'm at. So while the counter, all the counter is less than equals to 10, right? I want to do something. I want it to output what the counter is, right? Please type along with me so that you guys can be more familiar. All right. So I'm declaring a variable called counter and assigning it a value of 1. Okay. So at the start, while 1 is less than equal to 10, so this is true. So I will run this code. All right. So after that, I want to increment the code, right? I don't want to keep staying at 1. So I'm gonna plus equals to 1. This means that counter will now be 2. It will be incremented by the value here, which is 1. Okay. So now counter is 2. Right. So after this chunk of code, I'll go back to this condition. Is this true? If this is true, it will continue running this code until this is not true. So for example, if counter equals to 10, right? Then I'll output counter. Then counter plus equals to 1. So now counter is 11, right? So while 11 is less than equal to 10, so that's not true. Counter 11 is not less than equal to 10. So hence it will exit the while loop and come here. Right? Okay, all right. So, all right, let's test it out. How does it work? All right. As you can see here, we output 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and n, right? So this shows that once counter reaches 11, right? Because 10 plus 1 is 11. It will stop this loop because this is false, okay? And then it'll exit the loop here and we'll go to the end. Okay, I hope that's clear. So let me give you an example. What if I don't have this counter over here? What is going to happen? So if you think about it, counter will forever remain at 1, right? So that means this will forever be true, right? Since counter is never changing. So as a result, let's see what happens, right? As you can see here, I am stuck with an infinite number of ones, right? So this is important because this is important for while loops, especially because if you do not have a terminating condition, as in your condition it's not possible for a condition to end, you have an infinite loop and hence your code will eventually crash. So it's very important for while loops to ensure that your condition at the start here, your condition here, it is possible for that condition to be terminated at some point. So why, if I put +1, it works? Because eventually counter will be more than 10, and therefore it will work, right? It won't have an infinite loop. However, if I remove this, counter will forever be 1, and therefore it will have an infinite loop because counter will always be less than 10. So the loop will run forever, right? So therefore your code will crash. I hope that's clear. Okay, so let's move on to slides. So now we're going to while loops. Let's talk about for loops, okay? So for loops, they do basically the same thing, all right? But the syntax is slightly different. So this is the syntax. Don't be too alarmed by it, okay? It may be a bit scary at first, but we'll break it down. Right? So the for loop syntax is separated into 3 sections, all right? And they're separated by semicolons, right? You can see here. 3 sections separated by semicolons, okay? So let's break it down. Let's start at the beginning, right? So first, you have the counter, right? As mentioned earlier, every loop has a counter, right? To start the counting, right? But something to take note is that counter is not fixed. You can name this anything. It's just any other variable. It can be A, B, C, or I. A common variable name to use for used for for loops is I, because I stands for index or iteration, right? So I'm just using counter for simplicity in context with what we were doing just now, okay? So this runs only at the start of the code, start of the for loop. So counter will only be 0 at the beginning. After that, it will not touch this anymore. This is just to initiate what value the counter will be, okay? To start counting from, right? Right. So next we have the condition. This is the condition. This is the true or false, the Boolean value, okay? This will determine if the counter is less than 5, I'll keep going until the counter, until this Boolean is false, right? So since 0 is less than 5, it will run all the way until counter is, more than 5. So how does the counter increase? So the counter increases by this third section over here. So this is the incrementing part. So if you remember, as Lingsong mentioned earlier in operations, plus means plus equals. So this is just a short form, right? But they mean the same thing. You can write both. It's interchangeable, right? So this is run at the end of the code, right? Although it's in the first line, the computer will read this at the end of the code. So first, you'll initiate the counter to be 0, and then you won't touch it anymore. You'll run your code, you'll increment it, and then it will check if this is still valid, right? So you'll initiate it, you'll check the Boolean, you'll run your code, you'll increment, and then the whole process repeats until the Boolean is false. All right, so let's give it a try. Okay, so for int, I'm going to use I, since I mentioned earlier, I less than equals to 10. And semicolons, by the way, these are separated by semicolons, not commas, okay? Be very careful. Semicolons, not commas, okay? then I plus increment. And now let's see what happens if we do this. What do we think is going to happen here? All right. So we start off the counter at 1, okay, and then so long as the variable I is less than or equals to 10, I'll run this code. All right. So first, I is 1, so 1 is less than or equals to 10. So I will output 1, right? Sorry, I'll output 1. So once I output 1, I'll increment, right? As I said, the incrementing occurs at the end of the processing of this code, okay? So I output 1, then I'll increment it, and then I'll check again, okay? So I'll initiate the value, I will check, I'll process, I increment, okay? I initiate, I check, I process, I increment, all right? And that process repeats until the Boolean value is false, meaning in this case, until I is more than 10. Okay, let's run this and see how it works, okay? So now I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, as expected, right? So that is for loops, okay? So now let's practice, all right? So I've been talking a lot, so now let's get your hands into action. All right, let's take in an integer n, okay? And I want you guys to add up all the numbers from 1 to n and then output the final answer. For example, if n is 10, I want you guys to calculate 1 plus 2 plus 3 plus 4 plus 5 all the way to plus 10 and then output the final answer, which is 55, right? So you may wonder, how do I add all these up, right? How do I store this, right? So important concept, right, is a hint, right, is to create an additional variable, right? If you want to store something, you want to create additional variable because you repeatedly want to store the sum, right? You want to store it to the same sum. So you create additional variable answer, it can be anything. I recommend answer, right? And then use the loop, any loop you want, for loop or while loop, to repeatedly add to the answer n times. All right. So let's get you started, okay? So we have answer, and obviously one answer to be 0, right? Because all right, let's name it sum, all right? Sum, right? Obviously want it to be 0, right? Because at the start, nothing plus nothing, you get a 0, right? So yeah, so this is my beginning of the code. So if I can use a while, oh sorry, I would in n, all right? Then I'll see in n, okay? Then I will use a loop, all right? Any loop, use for loop, while loop. Let's say for, then you can write whatever here, and then you can repeatedly do this, right? Plus equals means you want to add this value to the sum, okay? Similar to while dot in. You choose either one. You choose to use for loop or while loop, up to you, okay? All right, so now we'll give you about 5 minutes to try this out. It shouldn't be too hard if you have been following along. So I hope you guys will get your hands on and practice, all right? I'll see you guys in 5 minutes. All right. Okay, some of you guys are confused with the for loop syntax, so I'm gonna put it on the screen so you guys can get it right. All right. Okay, just a few more, two more minutes for you guys to finalize your code. I'm sorry, it's a bit rushed. Okay, guys, so I'll go through now. All right, so just, I know some of y'all have, died or like burnt out, but just practice, it'll get better, right? So let's go through the for loop first, okay? So I want to count all the numbers from 1 to n, right? So I'm gonna start my counter. I'll just put counter as 1 because I want to start 1 to n, right? So long as it's less than n, right? I want to count it. Sorry. All right, I'll just put I, all right, so shorter. All right, so I'll start my counter at 1, all right? Then so long as I is less than or equals to n, which was the input earlier, then I want to do something, right? So then my sum, since originally it's 0, I just want to add I, right? Because it will repeatedly add 1, and then I becomes 2, and then sum will add 2. So now sum will be 3, right? So first, sum equals 0, right? But then after the first iteration, sum plus equals to 1, right? So now sum is 1. Then now the next one, sum plus equals 2. Now sum is 1 plus 2 equals 3, right? So on and so forth. So on all the way, right? So this is the for loop answer. Okay. And let's try it out, right? So let's okay, let's say 10. And then we get 55, right? That's the expected answer, right? So because I want to add 1 and then 2 and then all the way until 10 to a sum. Okay, hope this is clear. So now let's talk about the while loop answer. Okay. So for while loop, you have to remember you have to always have a counter, separate integer counter, right? Doesn't have to be name counter. It can be named I or whatever. I'll just name it I. So it's similar. And I want to start it at 1, right? Because similar to the for loop, I want to begin at 1. Okay, so we get at 1. I want to end at n. Okay, so I less than equals to n, similar to the for loop, right? So now sum, same thing. I want to add I. However, something different here is I need to manually increment I, right? So I plus equals to 1, which is the same as what it is here. Okay, so I initiate, similar to for loop, right? I initiate, I check the condition, I process, and I increment. And I repeat, I check the condition, I process, and then I increment. It's the same thing. All right. So now let's output sum and let's see what we get. Okay, 10 again. And we get 55 again, right? So therefore, these two codes work, and yeah, these are the solutions for this problem. Okay, I hope you guys understand. All right. So now, what eating? Right? I'll pass the time to eating. Building blocks admin. He needs to say some stuff. All right.
Hello everyone, so hope you've been enjoying the workshop so far. So actually this workshop team has some other parts that they haven't covered, but it's already 4+. So if anybody needs to go, I understand that you guys can head off, but please wait until I finish this message. And at the same time, but if any of you wants to continue on and stay for the next few parts of the workshop, please do. They'll be covering functions as well as lists. So if you want to stay for that, please do so. But otherwise, the recording will also be uploaded on YouTube. So that is something that you can refer to for the rest of the workshop. So with that, I want to just say thank you very much to the workshop organizing team. And if anybody is interested to become a workshop organizer, please do so. And I'll send a link in the announcements chat in Discord, as well as send a link into this chat in Zoom later. Because as a workshop organizer, I think it helps you to solidify a lot of your coding skills. Like I think this team has learned a lot about C++ through the journey, and it's a good way to spread your computational computational skills to the rest of the nationwide event. So throughout our other few conferences, if you're interested to help out, please do sign up. And I hope everyone has managed to learn something today. So before you leave, please complete the reflection form that I will send in the chat right now. If you guys would like to continue and stay on and listen in, please do. Thank you. For those who like to stay, we'll take a quick 5-minute break before we continue. For those who want to leave, please complete the feedback form. Thank you.
All right, guys, can you guys hear me? All right, so Sorry for the inconvenience that we have to overshoot because there's a lot to cover today. So, all right, so let's start functions, okay? So first, what are functions? Okay, functions. All right, so functions are basically a chunk of code that can be reused over and over again rather than having to rewrite the same thing multiple times, okay? And it's also very important for programmers because programmers like to break down the big problems into smaller chunks to perform specific things, right? Sorry about that. All right, so obviously, if you break down problems, right, it will make your code look clean and neat, okay? All right, so now let's look at the syntax. First thing you may ask, what's going on? Didn't Lingsong say everything should be in the main function? Why is there something outside of the main function? Hold that thought, okay? So I want you to understand that functions are the broken down sub-problems of the bigger main problem, right? So for example, if you have this small sub-problem that you want to do over and over again throughout your code, you don't really want to copy and paste the same few lines of code over and over again, right? You just want to store that instruction somewhere and have access to it whenever you need it, right? You don't want to keep writing those few lines of code again and again. So therefore, this is the use and the importance of functions. Okay, so now let's get into how to write functions. Right, so the first one we have here is the return type. Right, return type is simple. It's simple to understand. It's basically the data type of the information you want the function to return. For example, if I want the function to give me an integer, my return type is an integer. If I want the function to give me a true or false value, then the return type will be a Boolean, right? BOOL, right? So that's the return type. So about name, right? So name is basically the name of the function. It can be anything you want, but like Lingsong mentioned earlier, it shouldn't have spaces, right? So if you want to have a space, make sure to include underscores, okay? So now this right portion over here is the variables. In technical terms, these are called arguments, but I'll use variables for short. So these are basically the information the function needs to process something, okay? All right, so let's take this for example, right? Let's take this addition function that returns me the sum of two numbers, okay? So since I want the sum of two numbers, my return type should be an integer, right? So thus, I have an integer return type, and I take in two integers, okay? Take note, the information you take in, you have to redeclare it, right? You have to put the data type of it, okay? You can't just put A, you can't just put B, because the computer won't know what data type you want it to accept, right? So you have to put int A and int B, or can be whatever name you want. Just make sure to put a data type in front. And then I want to return C, which is the sum, okay? So this addition function takes in two numbers and gives me back the sum, okay? Similarly, I can write another subtract function, okay? This which takes in two integers and gives me back an integer, right? Which is the difference of it, okay? So what's the use? What's the point of writing all these functions if we can't use them, right? As I said earlier, we have to use this set of instructions, right? So in computing, we use this term called call. We call the functions, right? So how do we call the functions? It's very simple. We literally just write the function name and give the information it needs, right? So to access the values of the function, number one, we can use cout. We can output the value of this function, right? So this function returns the sum of 1 and 2. So in short, addition 1, 2 now has a value of 3. Okay, so after it runs this code, now this whole thing converts to 3. So now I'll cout 3. Similarly, for subtract, this whole value here will become 2 because 5 minus 2, 5 minus 3 is 2. So this whole value here will become 2. Okay, so I will just cout 3 and 2. But what if I don't want to cout? What if I want to store these values somewhere and do something with it further on? So this is where we can store them into variables, right? So as I mentioned earlier, this addition function will now have the value of 3. So now sum will have the value of 3. So instead of outputting it, I can store the value of 3 into this variable. Same with difference, right? I can store the difference of 4 and 2 into this variable, and then I can process it in the future. So let's try this out, right? Let's try this out. I can remove all this. Okay. Let's have these functions. Okay. Addition. I can also do this, right? I can just give back a plus b, right? I didn't have to create a new variable and insert the new variable and then output the new variable. I can just return a plus b, right? Because this still makes sense. I just want to return the sum, all right? So please tap along with me if you guys want to practice. Oh, as you can see, I've made an error, right? I have to put int. I have to declare the variable again, right? So now I return a minus b. Okay, let's extend this, right? Let's multiply, all right? Multiply int a b. Sorry, int a int b. Then return a x series b because x series means multiply, right? So now let's do, all right, let's just see out addition 1, 2, right? So so this will give me 3, right? Then now see out subtract 4, 2. Then this will give me 2, right? Now let's multiply 3 and 2, right? This will give me 6, right? Now as you can see, I'm just putting this end line here just so that my output will look neater, okay? So now let's try it out. Let's run, see what happens. Okay. As you can see, we did get the expected outputs. We got 3, 2, and 6, right? So that's what happens when we see out the values of the function, right? So because this value now becomes 3, this value becomes 2, this one becomes 6, right? So now let's try the other one. Why not? We store them, okay? So let's have sum, difference, and product, right? Now I'm going to store the addition, sum. I'm going to store the difference, subtract. I'm going to store the product, multiply, okay? And I don't need this, and I don't need this, right? So now I've stored it, right? But how do I know whether I've stored it, right? Now let's try this, okay? Let's try to process it. So let's do sum plus difference. What do you get? So now we're expecting 3 plus 2, right? So now we're expecting a 5. So see out, let's try again. See out, let's say product minus difference, okay? What do you get? You get 6 minus 2, so we expect a 4, right? So we expect 3 plus 2 to get 5, and then 6 minus 2 to get 4. So this is what we expect, all right? Let's try it out. Okay, like look, we got the expected outputs, all right? So this is how you use functions, all right? You separate them, and then is to break these problems down so you don't have to cluster them all here as well. Okay, now these are simple functions, so it doesn't make much of a difference if you put them here. But if these functions get very long, you're gonna have to repeat over and over again if you don't create functions, right? All right, so moving on. Now it's time for practice, right? So now we have this practice will technically go through everything we've done. If statements, for loops, you can use function for this. You don't have to. So, well, what does this mean? All right. I want you to take an integer n, use a for loop, and add each iteration 1 to n while processing the for loop. If the number is a multiple of 3, you times 2. If the number is a multiple of 2, you add 3. If it's both, like if it's a multiple of 2 and a multiple of 6, a multiple of 2 and a multiple of 3, like 6, just minus 5. If it's neither of this, you add 10. Now, as you can see here, these are conditions, right? Is a multiple of 3, is a multiple of 2, both, neither. This is quite familiar, right? We went through this earlier. If statements and the else, right? So let's go through this. So for example, if n equals 10, I want 1 plus 10, right? If n equals 2, 2 is a multiple of 2, so 2 plus 3. Then 3 is a multiple of 3, so 3 times 2. Then 4 plus 3, then 5 plus 10, then 6 minus 5, then 7 plus 10, then 8 plus 3, 9 times 2, because 9 is a multiple of 3, and then 10 is a multiple of 2, so we add 3 total, and this is my desired output. All right? So yeah, so I'll slash this question here. So do you think you guys would want some time to try this out, or should I just go through? All right. Since we are quite tight for time, let's just just go through it. All right. So this is just a recap, revision of what we have gone through so far, right? So what do we want? We want to take integer n, right? So let's take that. So in n, and take an integer n, right? Now using a for loop, right? I want to add each iteration from 1 to n while processing the following. Okay, so from 1, right? So someone just joined. Okay, so I'll start from 1, right? So from 1 to n, right? So earlier, like what I did earlier, less than equals to n, incremented. Okay, so I want to start my counter at 1 and then end it once it reaches n. Okay, then I'll increment it by 1 every time. So now, since we're done with the for loop, now let's do the processing. So if the number multiple of 3, so if how do you check if something is a multiple of something, right? So as I mentioned earlier about the even and odd, to check whether it's a multiple of something, we use the percentage sign, we use the modulo symbol, right? Which means the remainder. So if a number divides by something which is a remainder of 0, it means that it's a multiple, right? So if this equals to 0, this means that I is a multiple of 3, right? Because the remainder of I divided by 3 is 0. So therefore, oh, I forgot to add, we do need an answer at the start, right? Like before. Let's call it, yeah, this is called answer, okay? So ans, well now, plus equals times 2, right? So I want I times 2, okay? Because I is the counter, so I want I times 2, right? Please follow along if you guys are coding along as well. And then, all right, so if it's not a multiple of 3, what do I do? The question says I want to add 3, right? If it's a multiple of 2. If it's a multiple of 3, sorry, if it's a multiple of 2, right? So else if I percent 2 equals to 0, right? Then I'll answer plus equals to I plus 3. All right, let's all right. So now we've settled the first two. Oh wait, what about the third one? Both 3 and 2, right? Both 3 and 2. So won't it already come here? In why? Yeah. Oh, if it's a multiple of 3 and 2, won't this be true already? Okay, won't this part be true already, right? And then nothing else will, then everything below will process. But this is not the process we want, right? We want -5, but this is times 2. So what we can do here is that we put this in front. If I percent 3 equals to 0 and I percent 2 equals to 0, all right? So since the and requires both to be true, this is everything here is certain to be a multiple of 3 and a multiple of 2, right? So therefore, our ans plus equals I minus 5. right? So in this case, so for example, if a number is not a multiple of 2, but it's a multiple of 3, right? This won't work. So it's good, right? Let's add an else if here. Yeah, it won't work because it's good, right? Because we only want this if it's both, right? So we have to put this first because the computer will process this first. So we put this in front, okay? So if it's a multiple of 3, which is still valid, right? So if it's a multiple of 3, then this will skip this part and then come to here. And then this will be true, correct? So therefore, this will work for the first 3 conditions, all right? So lastly, now if neither means last result, right? So else, last result, else. If it's not a multiple of 3 and 2, not a multiple of 3, not a multiple of 2, last result, and plus equals I plus 10, right? So yeah, so that's the code, right? Right, let's see. Oh. Oh, sorry, percent, my bad. All right, there you go. Yep. 10, 4. All right, so yeah, so that's the answer. Now I'm going to pass the time to Gabriel, who's going to discuss data structures with you guys. Okay, so yes, thank you.
Hello guys, my name is Gabriel and I'll be going through the data structures. So before I go through data structures, I'm going to give a heads up that what I'm going to go through, it's going to be recording style. So I won't like give time for breaks and give time to do practice. I will immediately discuss the practice because we are very overshot on time. Okay, so I'm going to start now. So what are data structures? So data structures are basically a way for C++ to organize how different data types are stored together. So you'll understand more once I go through the examples of the data structures. So I'll be going through three most commonly used data structures, which are arrays, vectors, and maps. So first up, we have arrays. So what are arrays? Arrays are basically a series of elements of the same type placed in contiguous memory locations. What does this mean is that you can think of it as a series of boxes where you can store the values you want to store inside that boxes. So for example, let's say we want to store a sequence of numbers. Let's say 10, 20, 20, 10, and 5. So you can create 5 different integer variables to store these values, but that's very inefficient. For example, what happens if there are 100 sequence of numbers you want to store? So how we can do this easily is that we can use arrays, which is the data structure to store the contiguous values, and they must be of the same data type. So the syntax to declare arrays is first you declare the data type of the values you want the array to store, and this must be only single data type. So the array can only store one data type. Like if you want to store integers, the array can only store integers. Then after that, you declare the name of the array and you use the square brackets and declare the size inside that array. So that size is a fixed size of the maximum amount of values the arrays can store, and you can't change it afterwards unless you declare a new array. After that, you can declare the values inside the array using the equals operators followed by the curly brackets, and inside you will put the values separated by commas. So for example, let's say we have an array that stores 5 numbers as shown on the right. So the syntax to declare that in C++ is int for integer, which is the data type the numbers array stores, and square bracket 5 which is the size of the array, then equals curly bracket 10, 20, 20, 10, 5. So this creates an array of 5 integers, with values 10, 20, 20, 10, and 5. So for the next part, the values is actually optional. So you can create an array without declaring the values, like what Ling Song mentioned. Let's say you want to create an integer x. You don't have to initiate its value immediately. You can just do that later. So if we create string names 5, that creates an array of strings with 5 values, and it's uninitialized yet. So next, how do we access the elements of the array? Because that's how we use it, right? We need to access the elements first. So there's this weird thing in programming, in C++ and many other programming languages, where we count from 0 indexing. So what does index mean? So index is basically the position of each element in the vector. So let's say, for example, we have an array of char, and the values are A, B, C, D, E. So each of these elements has an index tied to it. So A has an index of 0, B has an index of 1, C 2, D 3, and E 4. So that's what I mean by we count from 0. The first element has an index of 0. So as you can see, when we see out letter 2, that means we're accessing the third element. So we output C instead of B. So the last part is something important you need to know. So this is a commonly used way to output all the elements that an array stores using a for loop, because we actually can iterate through the array from 0 to the maximum index and output the element one at a time. So I use I, which stands for index, but you can use a different name, just like Ike mentioned when he was discussing for loops. So yeah, next, here's another example. Let's say we want to create an array that stores the first 6 even numbers starting from 0. We can use a for loop to do that. So for int I equals to 0, and while I is less than 6, then I plus plus. So at first, when I is equal to 0, the first element, we change its value to 0 times 2, which is seen in this part, I times 2. So this becomes 0. Then next, when I is equal to 1, we change this one to 1 times 2, just 2. And so on, we iterate through the end until this is when I is equal to 5. So at the index 5, which is the 6th element, the value of that is 10, which is 5 times 2. So next, I'm going to go to Code Collab, and I will give you a context. So for example, let's say we have a teacher who wants to store the scores of his students. So let's say we want to have int scores, and there are, let's say, 5 students. And it has the values of 10, 20, no, let's say 80, 70, 90, 100, and 60. So this creates an array of integers with size 5 and the name scores. So if we want to see out scores 2, this will access the third element, which is 90. So the expected output of this is 90. And wait a minute. Okay, yeah, the output is 90. So if we want to output the whole array, we can use for int I is equal to 0, I is less than 5, I plus plus, cout, scores I separated by spaces. So the expected output of this, it should be 80, 70, 90, 160, because we're outputting the array. Yeah. So as expected, we get this. So what if we change the value of the array midway? So let's say one of the students actually has a different score than expected. So let's say scores 1 is actually 75. The teacher didn't count several marks. So now what happens if we output the array now? So the expected output is 80, 75. Yes, and you can see, even though we defined the scores array to be 80, 70, 90, 160 at first, we changed the element at index 1, which is the second element, to 75. So the output is 80, 75, 90, 160, and not 80, 70, 90, 160. So yeah, so moving on, let's go to practice. So try to write a program that inputs integers into an array of size n. So you can either input this n, or you can just define it and any number you want. Then output the number of elements that is strictly less than x, which is another variable that you can either input or you can just define immediately. So for example, n is 5 and x is 10. We have an array of 5, 3, 1, 10, 13. So how many numbers are strictly less than 10 inside this array? So you can see that there are actually three integers, 5, 3, and 1, which are strictly less than 10. So 10 is not less than 10, so it's not counted. So the output of this program should be 3. So let's try to code this out. I will go to practice.cpp. And I'll write out the starting first. So first we have two variables in n and x, and we input both of them. Then we have the array, which we can also input in numbers n. So for int I is equal to 0, I is less than n, I plus plus. So what I'm going to do now is I'm going to use a for loop to try to input the numbers into the array one by one. So cin numbers I. So what this means is that I'm trying to input the numbers one by one into the array from 0 to n minus 1. And after this, what do we need to do? So after this, since we have the array n and x, what we need to do is count the number of elements that are less than x inside the array. So how do we do that? So to do that, we can use another for loop to iterate through the array and find each element that is less than x, and then add it to a certain variable. So let's say a variable ans, which stands for answer, and is initially 0 because we haven't looked through the array yet. So we have this, and what we need to do now is we check the element we're looking at. Is it less than x? So does that sound familiar? So it actually is a condition that we can use inside an if statement. So if the element we're looking to right now, numbers I is less than x, ans plus plus, which is the same as ans plus equals 1. So we're adding 1 to the answer because turns out that this element is an element that is less than x. So we count 1 more. So by the end of this for loop, we should have a correct answer. So let's try to print out. So let's try this out. Oh, sorry, I should compile this first and run it. So let's say we have an array of 6 integers and x is 8. And let's say 1, 9, 6, 3, 4, 10. So as you can see in this array, the expected output should be 4. I mean 3, sorry, 4, yeah. So because 1, 6, 3, and 4 is less than 8. There are 4 elements that are less than 8. So the output should be 4. And yes, so this program is correct. So moving on, we're going to go through vectors. So what are vectors? Vectors are very similar to arrays, but the difference is that they have variable sizes. So like I mentioned earlier, when you declare arrays, you need to declare their size, and that is a fixed size, cannot change. So if you might be confused, if vectors can have variable sizes and it's basically the same as arrays, so why would you need to use arrays? So in the professional industry, arrays are still used because it's more memory efficient and it's faster. but vectors are also sometimes used because it's easier to use and it's more easily understandable. So let's go through. So before I go through what vectors, how to declare vectors and its syntax, I want to introduce this thing called methods. So some data structures have this thing called methods, which are functions that belong to that specific data structure. So only that data structure can use these functions, and it's already defined by C++. So you don't need to define it again. So the general syntax for that is the data structure name, and then dot, and then method name. So let's go through some of the methods that vector has. So first up, we have dot pushback. So let's say we have a vector v and a value val that we want to add into the vector. So pushback adds an item with value val to the end of vector v. So yeah, that's what it means. V.pushback val adds val to the end of vector v. And then there's also insert, which inserts an item with value val into a specific index in the vector v, and that index is, let's say, I. And in here, we use something called v.begin. I know this is quite confusing. I'll explain this later on, but just need to know that this is the syntax. So to insert an item with value val to the vector v, you need to use v.insert, v.begin plus I, where I is the index and val is the value. And we also have v.erase, which is similar syntax to insert. So it erases an item at index I in the vector v. And we also use .begin plus I. Then lastly, we have v.size, which returns the size of the vector v. So what's the syntax? To declare the vector, we need to first write vector, then arrowhead bracket, and then the data type of the elements the vector stores. And after that, we write the name of the vector, followed with round brackets to initiate the initial size, which can change later on because vector has variable size, and the initial values of the elements inside that vector. So initial value is optional. Technically, size is also optional. So here's an example. So let's say we have a vector called 3 5s, which stores three numbers that has a value of 5. So vector int 3 5s. So 3 is the initial size, and 5 is the initial value. So this is what's inside the vector 5 5 5. So let's say we have another vector called numbers, and it has a value of 10, 20, 20, 10, and 5. So before I go through the method usage, let's try to go through the diagram. So here's what the vector looks like visually. So it has, you can think of it as boxes, series of boxes that stores numbers, 10, 20, 20, 10, 5. So before any modification happens, this is what it looks like. So what happens after we go through this line when we put .pushback 60? So like I mentioned earlier, .pushback adds an item to the end of the vector. So if we put .pushback 60, 60 is added to the end of the vector. So the vector now has size 6, and the end of it is 60. So now what happens if we go through this one? So before I go through that, I will show you what .begin means. So .begin, scores.begin more specifically. Oh, sorry, this is a typo. It should be numbers. So numbers.begin, it should point to the beginning of the numbers vector. So as you can see here, it points to the first element of that vector. So the official type of .begin is actually iterator. It's quite complicated to explain what that means, but you can think of it, you can try to remember it as just we use .begin when we use the methods of vectors, and I'll show you later on that when we don't use .begin. So .begin points to the beginning of the vector, and we see here we use numbers.begin plus 3. So number.begins plus 3 points to the fourth element because this is .begin, and .begin plus 3 is 1, 2, 3. So it points to the fourth element, or the element at index 3. So this is before the insertion happens, and after the insertion where we put 15, value 15, into the vector v at the index 3, or score.begin, numbers.begin plus 3, the vector becomes 10, 20, 20, 15, 10, 5, 60. So the same thing for arrays. So it's numbers that begin plus 4 points to 10, which is the 5th element inside the vector or the element at index 4. So if we erase that, we can see that 10 is gone from the vector now, and the vector becomes 10, 20, 20, 15, 5, 60. So how do we access elements? So how do we access elements? Actually, basically the same as arrays. So we have a vector of doubles, now, where it's called numbers, and values are 1.5, 2.3, and 4.0. So when you output numbers 2, it should output 4.0 or 4, depends on the compiler. Because the element at index 2, which is the 3rd element, is the last element, which is 4.0. So how to output the elements of it inside the vector? We can use a for loop also. And the difference between array is that we can use the dot size method of the vector as the endpoint of the for loop. So we don't need to remember what the size was. We can just put dot size. So it should output 1.5, 2.3, or 4.0, or 4. So next, I want to make a comparison between strings and vectors. So if you think about it, strings are actually very similar to a vector of chars. Strings stores multiple consecutive characters, and you can add multiple characters to the end of it using the plus equals. And similar to having multiple dot pushback. So let's say we have a vector of char, we push back D and push back E. It's the same as having a string, and we add DE to the end. So if this code is run, it should output D, because the 4th element that the string stores is actually D, or it's the same as the element at index 3, which is D. So to access the characters inside the string is the same syntax as vectors of char. So next, I will go to Code Collab to see, to explain another context. So I'll try to comment this out first. So in the previous context, we said that the teacher wants to store the scores of his students. So we can use the same context, but when we use vectors, the advantage is that the size of this can actually change. So what if new students come in, right? So yeah, the vector can store more values than just 5. So it's the same, 90, 160. And if we output this, is less than scores dot size, I plus plus, C out scores I. So what I'm doing here is I'm trying to output the elements inside the vector. So what we have here, oh sorry, I should compile this first. Stop, and I'll compile this. Okay, now I can run. So here you can see expected before. Oh, sorry. So I should do this. So here you can see that it shows a warning. It's not an error, it's different. So when you have a warning, the code can actually still run. But when you have an error, the code cannot run. So why do we have a warning here? So if you read the warning, it actually says that scores.size is not an integer. It's a long unsigned int. And that we can't, and it might cause an error if we compare it with I, which is an integer. So you can ignore this warning because since scores.size is technically still a number, it won't cause any error. So you can just ignore this warning basically. So as you can see in the output, it outputs 80, 70, 90, 160, which is the expected output. So what if we change some things in the middle? So let's say a new student comes in with a score of 50. What is the output now? So the output should have an extra 50 at the back. So as you can see, that's correct. There's an extra 50 at the back in addition to the first 5 scores. Then what if we want to insert score 20 into the index 1, into index 1. So this should put the score 20 in between 80 and 70 because that's where index 1 is. So let's try running this. What is happening? Okay, hold on. Oh, sorry, it should be different. This should work now. Because this part is actually the part to initiate to declare the index we want to put, and this is the value. So I actually misput the two. So as you can see, 20 is between 80 and 70. So yeah, this works, and it's the same if we try to erase. Say we want to erase the element at index 2, it should remove 70. So as you can see, 70 is gone. So now let's move on to the practice. So the practice is we write a function that swaps 2 elements in a vector of characters and returns that vector with the swapped elements. So for example, swap A, B, C, D and 0, 2, where 0 and 2 is the indexes of the 2 elements we want to swap. It should return the vector CBAD, which is a vector with the swapped elements because the element at index 0 is swapped with the element at index 2. A is swapped with C. So since this is a recording style, I'm going to immediately go through. So let's try to go through. So the first thing we need to note is that we're going to make a function. So if you look at the question, the function should return a vector with the swapped elements. That means we want a vector of characters, because this should be the vector with the swapped elements. And let's call this swap. Swap, and it should have 3 inputs, as you can 3 arguments, as you can see here. The vector, the 2 indexes. So the first one is the vector char, which is input vector. Let's call it V, and 2 indexes. Let's call it index 1 and index 2. So inside here, we need to write the function. So before I go through that, I'm going to give you a hint. So the question here is that how do we swap the element at index I with element at index J? So that's the question basically, right? So the first thing that comes to mind is, what if we just change the values at there? So for example, we want to swap the elements at index 1 and the element at index 4 in this vector of characters, which is D, C, A, F, E, B. So the first thing we might think of is that we change this to the value of the element at here, which is at index 4. So let's try to do that. So here it becomes E, which was this one, and now that you come to here, you notice that you're actually stuck because what about this one? We need to swap it, right? So this should be equals to C, but we have no idea what it is now, because if we try to change this element to the element at index 1, it's actually the same because we already changed this element to this one. So we face a problem. So how do we solve this problem is that we need to remember what this element was before we change it, because or else we will have no way to change this to the correct value, which is the swapped element. So let's try to create a variable. Let's call it temp, which stands for temporary variable. So it should be equals to the element at index 1 before it was changed. So it's C. So after that, we change the element at index 1 to the element at index 4. So C becomes E, as you can see here. So now E, we need to change it to the temporary variable. And if we do that, we notice that we have successfully swapped the two elements. So let's try to code it out. So as I mentioned earlier, the first thing to do first is you create a temporary variable. That's char temp is equal to v at index 1, right? So what we do now is we change the element at index 1 to the element at index 2, which is this part. We change this to the element at index 4. So yeah, after that, we change the element at index 2 to temp. And we're actually almost done here. Since we have already successfully created a swapped version of the vector, we now just need to return that vector. So return v. So let's try to test it out. Let's say we have a vector char, A, B, C, D, E. So let's say VC stands for vector char 1. Oh no, let's just say VC is equal to this. And we want to change VC to be equal to the swap version of the vector, swap VC. Let's say we want to swap element at index 1 with the element at index 4, which is the last element. So swap 1, 4. Then we try to output it using a for loop. VC.size, I plus plus, cout VCI space. So the expected output is actually AE CDB. Oh, sorry, I should compile this first. So yeah, it's correct, AECDB. If we try another one, let's say we swap them at index 2 instead, it should be ABEDC because we swapped C with E. Yep, and it's correct. So this is the correct program. So next, oh wait, I should restart this. Okay, so now we go through maps. So maps is the last data structure I'm going to go through. It's a bit more complicated, so let's go through it. So first of all, what is maps? So maps is similar to a Python dictionary for those of you who know Python. For those of you who don't, it's okay. I'll try to explain. So what a map does is it basically maps a key to a value. That doesn't really make sense now. I'll try to explain. So I'll try to make a comparison of maps with arrays. So as we mentioned earlier, arrays have indexes. So each element here has a specific index tied to it. And this index ranges from 0 to whatever the maximum size of the array was. And it's always an integer. So 10 is tied to 0, 20 is tied to 1, 100 is tied to 2. So what about maps? So maps, actually, the index, or in the official term, we call the index in the map is the key. So the key can be of any data type. So in here, we use a string. So instead of 0, 1, 2, blah, 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 we use strings, Dave, James, and Albert. So 10 is actually tied to Dave, 20 is tied to James, 100 is tied to Albert. So it maps these strings into the values, the respective values. So the syntax is map, and then use an arrowhead bracket, type 1, which is the data type of the key. So in this example, the key is the strings, Dave, James, Albert. So type 1 should be string. Then type 2 is the values that the key points to, the data type of the value. And then after that, you declare the name of the map. And to insert values, to insert key value pairs into the map, you use the square bracket name, the name of the map, square bracket, the key name. So for example, if you want to insert Dave 10 into here, name Dave equals 10. So that will put the key value pair of Dave 10 into the map. So if you were to access Dave, it should output 10. So here, if you see out name and the respective key, should output the value corresponding to that key. So let's hear an example. Let's say we have a map of grades. So let's say we want to store what our grades were. So the string is the key, which is the subject of our grade, subject of the grades we want to check, and char is the grade we have. So let's say grades English equals to D. So D is tied to English. English is the key, D is the value, and so on. So if we output grades English, it should output D because because D is tied to English. So as you can see, the syntax is actually similar to arrays and vectors, but the difference is instead of putting index into the square bracket, we put the key, which can be of any data type. So maps also have a few methods, and these are the two which I think are useful. First one is dot size, which is the same as vectors, and dot erase, which erases the key with the value val and its corresponding value. So remember, this val is actually key, the key that we want to erase. And if we do this, it will also erase the value that corresponds to that key. So for example, usage of methods, we have map string and int, Joe to 25. So 25 is tied to Joe. String is the data type of the key. As you can see, the key Joe is a string. The value is the data type. The data type of the value is an integer. You can see 25 is the value tied to Joe, and it's an integer. So mron4. If we output the sides of the map, it outputs 2 because we inserted two key value pairs. But if we erase ron with the key value pair with the key ron, it will erase this thing, ron and 4. So if we output the size, the output is 1. So note that dot erase 4 will not work. So dot erase will only work if you put the key inside it, not the value. The reason for that is because many keys may have the same value. So for example, there might be another person called Rob who has a value of 4 as well. So if you put dot erase 4, that C++ will have no idea which to erase. That's why they make the syntax for key, like you put the key inside the erase. So next, I'll try to go through the context again. Let's try to comment this out. So using the same context, the teacher wants to store the score of the students. So let's say we have map string in scores. So what this is that this scores not only store the value of the scores, it also stores the name of the person who got that score. So that's why maps are useful, because it actually can tie to a different data type. So in the previous one, vector and array, each score is actually tied to an index. That index is not very representative. So if we tie it to a string, it can represent a name instead, which is very useful. So if we want to put scores, let's say Joe has a score of 90. Scores Ron has a score of 100, and Ike has a score of 15. Okay, so this map has 3 names and scores: Joe, Ron, and Ike, with respective scores of 90, 100, and 15. So if we output Ike's disappointing score, it should output 15. So I compile this file. So we run it. Yeah, as you can see, it outputs 50. So what if we change this value? For example, we change Ike's score. Oh no, he actually cheated. His score is actually 10. Whoa. So if we output it now, the value should be 10 because Ike's score is now 10. So yeah, it's correct. So, and then what happens if, oh no, Ike is cheated and is banned from the school. So we erase Ike. So scores.erase Ike. What happens? If we output Ike, it actually will output 0, not an error. So why this happens is because by default, the map will put a value of 0 to every key. So if you, let's say you output a non-existing student, it should output 0. So yeah, it outputs 0 because by default, every key has a value of 0. So if you erase, it will actually just make the value into 0. So, but it actually changes the size as well. So if you output the scores.size, it should be 2 because there should be only 2 students because IQ has been erased. So yeah. So now let's go to the last one, which is the practice. So using a map, write a function that returns true if 2 students are from the same class and false otherwise. So for example, let's say Mario is from 2SA2 and Carl is from 2SB3. So same class Mario, Carl should be false because they're from different form classes. Mario is from 2SA2 and Carl is from 2SB3. So let's try to write this function. So practice, let's delete this. Let's delete this. So if you look at the question, what the function returns is actually a Boolean because the same class should return true or false whether the 2 students are from the same class. So the data type of the function, what the function returns is bool, and then let's call it same class, and then we have the arguments. So the arguments actually there's 2 of them. It's just the names of the 2 students. So they should be string. Let's call it student1 and string student2. So how do we do this function? How do we do this? It's actually quite simple. So if we use a map, there should be another argument, which is the map, string and string. So what this map represents is actually the name of the student and his or her corresponding class from class. So if you use a map, it's actually very simple. We can just access the class of the student1 and access the class of student2 and compare them both. So are they equal? So we just return m student1 is equals to m student2. So why does this work? So if student1 has the same class as student2, both of this should be the same. So after using the equals operator, this should return true and false otherwise. That's why it works, because the only condition for this function to return true is that both of them has the same class. So if we try to test it out, let's say map string classes, which represents the classes of the students. So classes of John is let's say 2SA5, and classes of Johnny, no, let's say Ron is equal to 2AA1, and classes of Hank, let's say, is equal to 2SA5. So if we see out, let's say same classes, student1 is John, and so we want to compare the classes of John and Ron. So the expected output is actually false because John and Ron has different classes. John has a class of 2SA5 and Ron has a class of 2AA1. So let's try to see what this outputs. So let's compile this, run it. Oh, sorry. Map string classes. Oh, sorry, this is a typo. It should be 2S. So yeah, so 0 is, you can see here. So this is actually false, the value of this, but it outputs 0 because C++ actually cannot output false and true. It will, false is actually converted to 0 and true is converted to 1. So this is something to take note of. C++ will automatically convert false to 0 and true to 1. So this is actually correct because 0 actually represents false. So if we change this to Hank, the expected output is true or 1, which is what C++ converts true. So yeah, we get 1. So this is the answer. So don't worry, all of the solutions will be uploaded to the GitHub, which we will share later on. So the recap, we learned why C++ is important for the industry and for you. Then we also learned how to run C++. We taught you how to run it online using the code collab. Then we taught you basic syntax of variables, operators, and conditionals, if else, and loops, and functions, which is a set of instructions. And lastly, data structures, which is how the different data are organized together. So that is all. Thank you. You can ignore this because Yikting already gave exit ticket before. Thank you all for attending.